All right, so looking at graphing inequalities for our little problem of the week. If we're doing polynomial inequalities or rational inequalities or anything like that, basically what we want to do is format it so that the polynomial or the whatever the function is going to be on the left, and then our zero will be on the right. And that just makes it easier for our brain to follow the same process each and every time. There's nothing magical about this. It's just a way for us to understand more readily what's going on. So basically, I want this entire thing to be negative or zero. So once I factor this, I end up with this factored form of the polynomial, and that's going to make my life a little bit easier because 0 or the x-axis is going to be my boundary line, because if I'm above the x-axis, I have positive y values. If I'm below the x-axis, I have negative y values. And so this is, again, is another reason why we have 0 over here on the right-hand side, because it's a great boundary line or a boundary point between positives and negatives. So what would my 0 be here? If my factor is x minus 1, then my solution, my 0, my root, whatever you want to call it, is going to be positive 1. Okay, if my factor is x minus 3, then my solution, my 0 or my root, is going to be positive 3. And if my factor is x minus 4, then my 0 or my root, my solution, my x-intercept is going to be 4. So notice that I now have 4 distinct boundaries. I've got from here to the left, I've got between here, and then from here to the right. So we're just going to grab some friendly test values and we're going to see what happens. And this is another benefit of leaving this in factored form, because I can rapidly see what sign it's going to be. I just want to know if it's positive or negative. I really don't care what the value is that pops out. I just want to know, is the value I choose going to land me above the x-axis, so it'll be positive, or is it going to land me below the x-axis, so it's going to be negative? And so I'm going to grab random, really friendly test points. So one of the test points I'm going to grab is going to be a 0. Why? Because that's easy. Okay, so I'm going to grab 0 for a test point on this interval. I can grab anything between 1 and 3. Well, 2 is a nice friendly number between 1 and 3, so I'm going to grab a 2. Between 3 and 4 is not so friendly, but I can grab 3.5. So I'll grab 3.5, and then after 4, just to see a rapid big effect, I'm going to grab 10. Okay, there's nothing magical about the red numbers that I just wrote. It's just friendly numbers that are on the interval, and that's what I want to use. So, looking at this, I am now going to use my factored form. So I have an x minus 1, x minus 3, x minus 4, and I want that to, I'm going to evaluate this polynomial function in factored form with each one of these 4 test points. So I'm going to start with a 0. So if I use a 0 minus 1, 0 minus 3, 0 minus 4, again, I personally don't care about the value that happens. I care about the sign that pops out. So 0 minus 1 is negative. 0 minus 3 is negative. 0 minus 4 is negative, and a negative times a negative times a negative is negative. Okay, so this interval over here is going to be below the x-axis. So now let's try 2. And let's change pen color. No, let's not change pen colors. Okay, so we now know that. So I'm going to grab the 2 on this interval. So I have an x minus 1. I have an x minus 3, I have an x minus 4, and I just want to know about the effect of this test point on the sign. So that's going to give me a 2 minus 1, a 2 minus 3, and a 2 minus 4. So 2 minus 1 is positive, 2 minus 3 is negative, 2 minus 4 is negative. So a negative times a negative is a positive, and a positive times a positive is positive. So on this interval, my function is going to be above the x-axis, somewhere up there. So let's grab another one. Let's grab this test point of 3.5. So I've got x minus 1, x minus 3, x minus 4, and I'm going to use my test point of 3.5. So 3.5 minus 1, 3.5 minus 3, 3.5 minus 4. So 3.5 minus 1 is positive. 3.5 minus 3 is positive. 3.5 minus 4 is negative. So a positive times a positive is a positive. A positive times a negative is a negative. So in this interval, I'm going to be below the x-axis. Okay? And my final interval, I'm going to grab 10. You could grab 1,000,000. I don't care. So this final one, I like using 10 just because if I'm to the right of something, because 10 I can rapidly see the effect. So x minus 1, x minus 3, x minus 4. It's one of those numbers that I really don't have to think about. So a 10 minus a 1, and I'm going to write it down so that you can see what I'm doing, is going to give me 10 minus 1 is a positive, 10 minus 3 is a positive, 10 minus 4 is a positive. So positive times a positive times a positive gives me a positive, which means I'm going to be above for the rest of that interval. Okay? So I want to know, where does this thing end up being less than or equal to 0? So the or equal to is important because in interval notation you're going to tell me using hard brackets. So this is less than 0. So from negative infinity to positive 1, I am going to be below the axis. Where else am I below the axis? Between 3 and 4, I am below the axis. So from 3 to 4, I am below the axis. Notice as well that you used all 3 zeros in your notation, which means that's where I've got my hard brackets to say that it's also equal to 0. So this is the intervals, or that's the interval notation that will satisfy this polynomial inequality.